Hi, welcome to the video on tables in Saltcorn. In the previous videos, we've seen how to create pages, and we've gone through some of the administrative settings. We've seen how to create a menu and change other options. That's all fine if you just want a static page, if you want every visitor at any time to see the same thing. Then you can just use pages and we're almost done here. But that's not what Saltcorn is really good at. If you just want static pages, you should probably use something like Webflow. In this video, we will start to dive into how to generate dynamic content, how to create websites that reflect content that changes, that is possibly generated by the user, that could maybe be a large data set that you have from somewhere, or any other kind of dynamic web page that looks different. Could be a social network, could be a to-do list, whatever you like. So the first step in that is to set up your tables. That is where you store your data, and that happens over here on the Tables tab of the welcome page, or there is also a setting here on the menu called Tables. After you have done that, you need to create views, which are little snippets of a web page that display the data from the tables. So the views are the links from the tables to what is shown to the user on a page. We'll do views in the next video. Today I will just focus on tables and how to organize your data. We will also, in these first few videos, just talk about a single table. It is possible to link multiple tables. That's what you use keys for. But in this first video, both on tables and also on the next video on views, we will just stick with a single table. Before I show you how tables work in Saltcorn, I do, however, want to switch to talking about spreadsheets to motivate some of the ways in which these data are organized. When you first start using a spreadsheet, I think it's very natural to use it in a very unstructured way. So here I've just done a little bit of an example of how you might use a spreadsheet just to do a simple calculation. So I'm trying to do a calculation from chemistry on the amount of sugar or salt I need to dissolve in order to get a certain concentration in a certain volume. And you can see some of these are numbers that I've entered, and some of them are equations that I've calculated based on the other parameters. And you can see that this is not laid out in any particular way. Which is fine. That's the way you use spreadsheets if you just want to do a simple calculation. But I would suggest that there's a different way of using a spreadsheet, which is much more structured. So here I have created a spreadsheet from that might be it's a list of people, a list of persons that might be from a sales database or customer database, or they might be members of a club or something like that. And here I have a very specific structure. In the first line, I have the name of the column, and so the data are organized in by columns and by rows. So the columns going down tell you that there is a particular piece of data, a particular type of data. In the first column, it's the name. In the next one, it's the date of birth. The rows going across denote a single case or a single record, or we often just call it a row. And that is a single observation. It might be a single person, although it might be a single point in time or anything like that. It might pertain to a company or whatever you have. So, but going across, the data are linked. So this person was born as that day and lives on this street, and this is her telephone number. But going down, the data are organized all in the same type of data. So these names are not linked, but they are all of the same type. In this case, it is a piece of text, and that piece of text also has an associated name. In this case, that is actually the name of the person, but over in this row, it is the date of birth. So that tells us for each row, what does that cell, that single measurement, tell us about that person. Okay, so this is much closer to how we use a database. So this is in fact a small database that we have in front of us. So we call the columns, we call fields, or we also sometimes call them columns. And each field has a name, which in this case is name, date of birth, address, etc. And it also has a type, which in the case of text, that is what we call a string. So string means a bunch of characters, of letters. Or in this case, some other types we have here are, this is a date. So this is the date type. In Saltcorn, we have a date type. And again, so we have some more strings here. The city is probably a string. The postcode might, I don't know how you would capture that, but you could do it as a string. Often, you can always represent things with strings, but you lose a lot of structure. So for instance, you could put the date you could write it in your database just as a list of characters. But then you're missing out on some structure in your database, and it's best to have as much structure as possible. And then the telephone number here, you might just represent that as a number. So at least then you make sure that you can't put in characters in the telephone. Now, you can still do calculations even when your data are structured like this. So I am going to add a column called age. So the internet tells me that if I want to calculate the age in Excel, I have to use the following equation. Today minus the date divided by 365. I can tell already that this is incorrect because there is not 365 days in a year. That ignores leap years, but let's ignore that for this video. So when I first do this, I get something funny. I get a date, but that is in fact because I have to format it. So in a way, this is telling, in database speak, this would be telling Excel what type of data I'm expecting to have in that column. And so I have to change that not from date to a number. So here we go. That is the date. That is the age. And I think, as far as I remember, the internet also told me that if I wanted a whole number of years, which I probably do, I should put int in front. So let's just copy that down. Okay, so here we go. We've got the age now. So as you'll see here, you can still do calculations when you have your data in this type of tabular format, but those calculations tend to be repeated across all the rows. And we have that in databases as well. We call that in Saltcorn, we call that a calculated field. Now you can do a different type of calculation. So let's say I'm interested in what is the average age of the person who's, maybe they're a member in a club. So then in Excel, average, and then I have to select all of these numbers here. Okay, so that is my average age. So notice how this calculation comes outside this tabular structure, so it is no longer really belonging to this column. I could have put that box anywhere else. So when you think of the spreadsheet as having this tabular structure with rows and columns, there's nowhere really to put, these calculations, but we still can do them. So again, we have those in a database, and we call these calculations across rows, we call them aggregations, because they aggregate multiple columns. And so we talk about aggregations that count, or that do averages or sums or products or whatever you like. Now, in this example, I had one row for every person. There's another way of having a very similar tabular structure where you have one row for a time point for measurement in time. And so here I've downloaded a data set online. So each row here is a day, and they follow one after another. And then this is a measurement of the carbon dioxide on top of a Hawaiian volcano. So, you can see how this goes up and down, and there's various different other information associated with that day's measurement. But you can see here how, again, we have fields, which are dates, and then some measurements. And then we have rows, which pertain now not to individuals, but they pertain to a specific point in time. So we call this a time series. But again, in a database, you would represent it in exactly the same way. You would have a fields, you would have rows for each time point, and fields for each of the pieces of information that go with that time point, and one of those should be the date at which the time point is made. So I hope it's obvious that the date here serves a very different purpose than the date in the previous spreadsheet, which was the date of birth. One last format that you see quite a lot in spreadsheets, and that is the format favored by accountants. So often when you see accounts, end of year accounts, management accounts for a company, it's laid out something like this. So across the top, so here in the columns, we have a year. So these numbers here correspond to 2021 and 2020 here. And then we have some categories in the rows that have expenses in different categories, and everything is broken down into expenses and income, and a summary net income at the bottom. So I just want to make two remarks about this. You do see this from time to time, also in other contexts. And the first is that, at least to a first approximation, I would suggest that here we should think about that in the same way as before, but where the rows and the columns have been swapped. So in fact, these are the rows that correspond to one particular point in time, and these are like our fields. So office supplies is a field, and so is salary. So in Saltcorn, we call this a transposed view. In mathematics, transposing means to swap the rows and the columns, and that's essentially what's happened here. So sometimes the display of the data does not reflect as transparently the organization of the data, and we will see in Saltcorn that you have many different ways of displaying data from the table. So this is the transposed view. Now, the other point I want to make about this is that these numbers are probably not the values that are recorded in the database. That is, this is probably not a view of a single table. The way you would have this in an accounting system is you would in fact have many different transactions, one every time you bought a different piece of office supply, maybe one for buying a pen and a piece of paper. And for the salaries, you would have them every month. You would have them for each person. So these are in fact not really a view into a database table. They are a summary across many different rows, each of which represent a transaction that happened at a particular point. And then those have been grouped, first of all, into 2020, 2021, and then they have been grouped into different categories, depending on whether they were expenses or income, and how those expenses have broken down. So we will also see this much later in Saltcorn, how you can create summary tables of this form. Capture this kind of tabular data structure where we have data organized by rows and fields in a Saltcorn application. So every application in Saltcorn is associated with a database. A database is a collection of tables that you have over here, and every table contains fields and rows. We've already got one table here, which is the users table. It has a row for every user that can log into the system. But let's create a new table. You can do that here. Let's do the table from our spreadsheet with the persons that we can add to this database. Okay, so when you've created a table, you see a list of fields here, and there's already one field in every table that's created for you. It is the ID field, and that is what is known as a primary key. It is a unique value for every row, and Saltcorn has this for every table. Normally it is an integer, a number, but you can also change it in case sometimes people prefer to have what's called UUIDs for primary keys for IDs. But let's just stick with the integer that we've got here. We don't need to do anything. It's already created, and it will already be added for every row. But we do need to create our other fields. So first we're going to create a bunch of fields, and then we're going to add the data down here. You can in fact add a field after you have added some data, and then that will be added to every row in the database. Right now we have no rows and only the one field, the ID, that's already built in. So let's add another one. So let's add the full name. So I need to write a label for that field that I'm adding. I'm going to call it full name. It's okay to have spaces here. It will be abbreviated or changed into a variable name automatically. So full name is fine. You can also add a description if you have some extra information about this field. But in this case, I think full name is fairly descriptive of what we're trying to do. And then you need to set the type. There are a number of types already built into Saltcorn, and you can add more by installing plugins. I can just quickly go through these. A string is actually what we need here for the full name. A string is kind of computer science speak for a bunch of characters, a small piece of text that we can have as a field in the database. So this is good for full name. It'll be good for city names, addresses, etc. Anything that's got words or descriptions. We could also have an integer that's just a number, a whole number. We can have a bool, that's a Boolean value, a true/false value. Then there are dates, which actually includes both the day and the time point at which something occurred. You can have float, which is a floating point number. That is a number that has decimal points and sort of not necessarily whole quantities. You can have color. Then we can reference a file. We saw in a previous video how to upload files. And then you can have these keys. A key is a reference to a row on a different table. We'll talk about all that later, about how you can link different tables. Right now, we're only interested in a single table, so I won't do any keys. So the full name is a string. That's a good type for that. And then I have some settings down here. One thing is that you can say that a field is calculated. That means that it is calculated from the other values on that row. It's not really appropriate for the full name, but it could be appropriate for something else. Then there are two more settings here. One is that you can mark the field as being required. That means that there must be a value in every row. And in this case, this is probably appropriate. So let's make that a required field. If a field is not required, then there can be a null value, or what we call a missing value. It might be appropriate, for instance, if you have a database of your customers, you have a field that's the age, but you don't know the age of every customer. Then you can make this not required. The other option is unique. Unique means that this value must be unique across all the rows. So here you have to think a little bit about, is it possible that there might be two rows, in this case that would be two persons, with the same full name? And, we could easily have 2 John Smiths. So in that case, I would make this not unique. You already have one unique field, which is the ID, the primary key. So that's good enough for this case. Once you press next, there are some settings that depend on the type. And because we made this field a string, here are the settings, some attributes you can mark for that string. For instance, some of you know about regular expressions. You can say that this string must match a regular expression. You can have a length, a maximum length, a minimum length. You can also have some options. So for instance, if I had a traffic light color, I might type in red, yellow, green here. In that case, that means that this string can only have one of these 3 values. But since this is a full name, I want to leave it open to not be restricted to options. You can also use fields to have translations. So you can have one field being a translation of a different field into a specific language. But for the moment, we're not building a multi-language app. Okay, so now I have my full name field here. And you can see it's already got a variable name, which is the down case, and what's it called? It's got an underscore instead of a space in it that is derived from the label here. Let's add another one. Let's add the date of birth, which we had in the spreadsheet. So I'm going to make that a date field. I will leave it as not unique, not required. And that did not have any options. What else did we have? We had address. I'm going to leave that as a string. I'll leave it as not required in case, for instance, this is a customer database. We have some customers. We don't know their addresses. Okay, so now I've got a reasonable number of fields here. Let's just go with that. And I am going to look at these data. So here I have no data, I have no rows, but there is a built-in table editor in Saltcorn where you can see the data. Now I can add rows. Okay, so if I want to add John Smith, the date of birth is going to be, let's set this to something like 1984, April 10, 1984. That sounds good. We currently have to set the time as well, but we will be able to hide that later because it's not really appropriate for that information. And let's say Gizzard Road. All right. Okay, so now we have one person in our database. We have some fields, and we have one row. But I want to show you that we didn't actually have to do any of that work. We could have taken a shortcut to creating the table. In Saltcorn, if you go to the table page, you have this facility to create a table from uploading a CSV file. CSV here is short for comma separated values, and it is a common format that you can export from spreadsheets. So let's go back to Excel, and I want to export this spreadsheet as a CSV file. First of all, let's get rid of our calculations here. Let's just delete that. And now I can save it as a CSV file. I choose CSV down here. Okay. And now Excel is going to do some Excelling, but we have nevertheless saved the file. And now if I switch back, I can now choose this file that I have saved. And let's call this people1. And that's it. Now we have created a table. the fields are created from the CSV file, and you have the 5 rows imported in here. The only thing I will say I am not happy about is that the date of birth is not captured as a date. It is a string. So I really should do something about that and see if we can capture a wider variety of strings and recognize that they are in fact dates. But other than that, we have all the data that we imported into the spreadsheet, and we've created our table without doing all this work of entering the fields ourselves. I think that's it for this video. In the next video, I will show you how to create views of these tables, one of these two, and we can see how we can use views to display the data in these tables to users in a variety of different forms, that is in lists and in forms, and just showing one row after another. So that will be the next video.